Hey, everybody. Can you hear me well, Valentin, right?
Yes.
Okay. So hello, everyone. Thank you very much for attending this webinar. This is our second in this series that we have started this year. Well, happy to see from the sign-in so much interest. Looks like definitely there is some innovation going on in the industry. Well, I'm Axel. I'm the president at ENGworks. As you might know, we are a BIM services company, so we have been doing VDC services forever. And a couple of years ago, we started this division, which next to our ENGworks logo, you're going to see the GigSkank, which what we do is help our clients automate workflows, integrate their systems, develop software in general to make their operation more efficient, right? Like using our experience, using the tools within our industry ecosystem, we try to help our clients become more efficient. So we call this division internally again the GigSkank. And Valentin Noves, who is our presenter today, he's our Director of Innovation, and he's the one that runs this team. So the idea is in about 40 minutes, plus minus, he will be doing this presentation, and then we'll leave at the end some time for questions and answers. And we make sure we'll leave our contact information in case you have questions or anything on the content of this presentation or any other add-in script or development that you guys are looking to do. So with this, Valentin, I leave it to you.
Perfect. Thank you, Axel. Basically, why are we here today? We want to show how to set up a process to develop add-ins in your AEC company. As a starting point, why should I create an add-in? Basically, there are like many answers to this question. I think the best ones that illustrates why are first automation, like, hey, I want to do this or that in a more efficient way. I don't want to use my time on something that I can automate. To add value, like to do something that I cannot provide to my clients today because whether I don't have time or I don't know how to do it or any other reasons. And then interoperability, which is a really major thing in our industry that we use so many tools. So it's important to connect different data silos between each other. So what do I need to create an add-in? Let's start by showing this. In most cases, if you have never created add-ins or you have just some coding experience, you might think it's just as easy as start coding, doing some lines of codes, and suddenly you have an add-in. Like you just need to know how to code and that's it. But we have done this so many times, and at the beginning, I think we thought that too as well, and we know that that's really far from the truth. We divided the way that we create any add-ins on 6 phases. First, the analysis, then design, going through planning, development, publication of the add-in, and then getting feedback from the users. As you see, there is just one phase where you actually do actual coding. And not also that, the ecosystem of the amount of tools that you use for creating an add-in, it is not just Visual Studio, which is a platform that you can use, for example, to create add-ins, but it's more vast than that. This is an example of all the tools that, no matter if it is like a small add-in or a big add-in, we always use all these tools as a base, and I'm going to show you how to use them. I think someone is not on mute. Okay, there we go. Sorry, Nauman, I've just muted you. So, and I think this is the most important thing of this webinar. You have to always remember that it is important that you're just developing or coding your add-in on a 30% of your time, and 70% of your time you're doing all the things. If you have like different percentages, like I don't know, you're 90% of the time coding and just 10% doing the analysis or planning, you might be doing something wrong, or it could be not the most efficient way to develop your add-in or your software solution. So let's get into it. How to create an add-in? Let's start with the analysis, as we mentioned. And I'm going to start from the beginning. And this is one of the most critical things in all the steps of the development of the add-in, which is gathering the requirements. Me as a professional of the AEC industry, I've seen many times that the people that have more experience in your company, or the guys who know more about the business, are the guys who are more busy. They don't have time to tell you like, hey, could you please automate this? Or it would be a great idea to do an add-in to do this or that. So it is important that the way that you are allowing your users to give you that information, it's super easy, and try to that they only have to do it once. Sometimes you use emails, for example, it's a go back and forward of emails like, hey, what do you want it to say about that add-in? Do you want it to automate the way I model pipes in Revit? What's the size of the pipes? And all those kind of like small features and details of your app. So for that, we're using a software called Jira Service Desk, which is a tool that helps you. Essentially, it's kind of like a mix between a form and an email. The way set it up, it's you set up an URL, and everybody knows if you get to, let's say, www.addins, the name of your company.com, they will get into this form. So it's super accessible from your phone or from wherever you are. And then you can set up categories like, hey, I wanted to use a Revit thing, a Navis thing, or any other software. If it is a new functionality or what. If it's how much time it's saving to you, or how many times are you using that tool, and those kind of things. Then after this form, they will get an email letting them know like, hey, we got this, like the development team got this and it's working on it. The other good thing is like the team get that request, and now they open a channel with that person, and if there are any other details that that person might have forgotten, like, I don't know, the color of the add-in, the way it should open or work, they can contact to them directly from the platform. And after that, we can use that same request and all the information there to take it into Jira. Jira is the software that we use to manage our software programs. It's vastly used in many software development companies around the world. I will give you more details ahead in the process. So it automatically creates a task to like, hey, could you please start analyzing this tool and tell us if it's viable to do it or not? And that leads us to, and of course, it adds to the backlog of all the tools that we might have to develop. And after that, that leads us to the second step, which is to analyze if it is worth to develop or not. First thing you need to know is like money or hours? Like how many hours I am saving my users by developing this tool? Is it a one project thing? It is something that they use every day. And then we calculate how many hours are we going to save them in a year, for example. It's going to be 1,000 hours. It's going to be just 10 hours. How much? Then we try to estimate, like at least like a ballpark number of how much time it's going to take us to develop this specific tool. Like, hey, it's going to take us, I don't know, 100 hours. Okay, how much money that represents? And then finally, we check whether we have already created something internally, because that happens a lot when you are a big company or you have many developers. Someone might have already developed something internally and you don't know, or there might have already be something in the market out there. So that's also super important, because it is not worth to develop something if you already you might already have something out there that it's completely free, and it solves the problem that you're looking to solve. So we take all that information to basically calculate the return of investment of the tool, and we always complete tables like this, where like we check what is going to be the cost, um, if we're going to get the return of investment in less than a year, for example, I don't know, 10 months, and how many hours are we going to save to our users, which in our company, there's like just internal professionals. We check, we have an internal solution now, there's not an available internal solution. We always try to find at least 2 different options of external solutions that are out there. So maybe I can find an add-in that is like, I don't know, I pay $150 a year, and it even does the work better than my solution. So it gives me an added value, and it gives me an ROI in 2 months, I don't know, and it's also cheaper, so it's going to be faster. And then how many hours is going to save? So it is worth to consider, like, hey, do I put, I don't know, one of my guys 2 weeks, or should I just, I don't know, pay $150 and get something that's an external tool? So after, let's say that we decide to continue with the process of developing the internal tool, we continue with the documentation, and we do product requirements. It is important that you have a place where you centralize all your documentation. In our case, we use Confluence, which it's another tool of the Jira ecosystem. It's useful, it's easy to use. I promise I don't work for Jira, I just use their tools. For example, right now I'm just showing an example of the documentation of the process that we have internally for our tools, and what do you have to do, and I have a description, and for example, I have all the steps that you have to follow to create your documentation, and you can click like, hey, how can I complete this task? How can I do it? So I go here, and I can get a detail of all the information that I have to do to complete that specific task. So you start completing this document, which is the product requirements. It's important that it's clear. It's important that you have set the goals there, that you set a problem statement, like what's the problem that you want to solve. The proposed solution, like, hey, it takes too much time for me to create, I don't know, tag fittings. I want a tool that automatically create tag fittings for me in Revit. Okay, what's the proposed solution? An add-in that creates, I don't know, supply mechanical ducts, pipes or fittings for Revit, for example. How it is expected to work. It's important to be super detailed here, because these are the steps that the developers are going to follow. Then exclusions. And this is super funny. When you develop, most of the times you feel that you can continue developing a project forever because there are no limits. You can always add new features and new stuff, but you have to know when to close the project. So it's important to know what the exclusions are so you don't continue investing in things that are not adding a lot of value to your project. Oh. And then the storytelling, how exactly the tool is going to work. If I click this button, it's going to do what? It's going to create what? If I select this category, what it's going to do, where that information is going. So a step-by-step of how the functionality of the tool is going to work. And then any extra features that you want to add or you want to explain in more detail. After you have done all those steps, you move into design. And you start with the software architecture. This is another thing that it's common, at least for us. I love coding as many as the guys who works with me. And when I get a new project, I get super excited. I'm like, hey, let's open Visual Studio or any other tool and let's start coding like crazy, because we're geeks. These are the things we love. Like any programmers, we don't like documents, to be honest. We just like to code, and that's sometimes it's a problem, because if I don't know what I'm going to code, I'm gonna many times invest a lot of time in things that then my product owner is gonna come and tell me like, no, that's not what I wanted. The user, he doesn't want that. I will have to like remove that, create a new functionality, or and that leads to a lot of time wasted. So no matter if it is like a small add-in that it does just one small thing, it's important that you design your architecture. For that, we use a tool called draw.io. This tool, it's simple. It just allows you to group the different elements of your architecture and then show the connections between them. An example could be, hey, I have an external database with, I don't know, information of the categories or prices of my duct fittings, my pipe fittings, or any other elements that I have. Okay, I'm going to group it in like external databases here. Then I can say like, I want the report after, like I do a quality control in a Revit project, I want the report to be mailed to you. Okay, I'm going to do a mailing separately, and so on and so forth. So the idea is that you take all your product requirements and you convert it into this, like Legos. You need to think like Legos. Like my project is going to be, I don't know, 10 Legos, 50 Legos, whatever is the number depending on the size of the project. But it's important because then you know how each part works, and then down the road you can divide them in tasks. So if I'm a programmer and I know I have 50 tasks and I have a detail of all of them, I'm going to be super efficient because I'm just going to be coding exactly what I have to do. If I don't have this, I might have to think a lot in the process. And then another thing that it's important when you code, it's that you design, you choose a pattern for the ones who are not. These are all example of patterns. For the ones who are not familiar with the term, basically it's just the way that I'm gonna organize my architecture, the way that I'm going to organize these Legos and how these Legos are going to connect. Us, for example, and I can show you in a specific tool, we use a lot of the singleton pattern. Singleton pattern is this. This is Visual Studio. I'm just showing some code. this is just one functionality. This is, you see here, this is one file, one file, and it's one class, one functionality. What it does, this one, for example, is a function that what it does, it checks if an element it's a number or a text. Just that, just one thing. So this is a Lego for me. This is a small piece of code that I know that is super generic. So if in the future I want to take it to another project, I can do it because it's a generic thing. I can use it in any project. And compared to, I don't know, this or maybe this is like a class with many functions inside it and super long code functions. And this makes everything harder because I'm doing many things in the same function. And also every time I want to adjust something, I have to read line by line and see where I'm making a change or not. So a pattern, it's important. No matter if you're just, let's say that you're not coding this yourself, it is important as well because you might be paying someone else to code it, then you own the code. And next time down the road, in a couple of months, you want someone else to modify it, it's gonna be a pain in the A if it's something that's not tidy. We always make jokes about the singleton pattern because it's just one function, one class. So, like, sorry, I thought the room wasn't occupied. If you have a class and there is already a function inside it, you cannot use it. So it's like a super nerd joke. And then we move to the next phase of the design, which is one of my favorites. It is the user interface design. We use a lot Photoshop, Adobe Illustrator, and Adobe XD. These are kind of tools that we use a lot for this. The first thing you need to do when you're creating your add-in is define a catchy icon, an icon that not only it's appealing, but also it's self-explanatory of what the tool is going to do. I don't know, this add-in, for example, this icon here, it's an add-in that we develop to find information of elements in Revit. So we try to be as easy to understand as possible. For this thing, Autodesk, they have developed something that for all the icons design, Autodesk, they have developed guidelines. They're like easy to follow, and I recommend you to use them. They're a little bit old now, but they're still really good. I'm just showing them on the screen right now. They guide you through many steps, like the parts that they recommend your icon to have, like a main body, like an accent, a badge. They recommend you different badges or different main bodies to use. They recommend you colors and how you mix those colors to show different things. Like when you remove something or you pin something, use red, for example. When you're adding something, you might use light blue, or you might use green when you're creating something. So those are things that help you a lot, and it's super nice, and maybe it might help you to create a standard in your company. Let me go back to the presentation. And then, oh, sorry, let me go back. Just one thing, when you create your icon, what I always do at the beginning, I create 3 different icons, a 25 by 25 pixel icon, which is the one that I'm going to use for Revit. That icon, it's the icon that you see here, for example. You see this value finder is this 25 by 25 pixels. If you make it bigger or smaller, it's not gonna look good. So you better do it right at the beginning. And then the 120 by 120, it's an icon that you might use in your website or these kind of things. For example, this is the 120 by 120. And then finally, I always create the icon with the same font that shows the name of the tool, and I use it for the starts of videos that I upload showing the tool. Another important thing that is nice to use, and I personally recommend it a lot, it's Google Material Design. Google Material Design are guidelines on how to design properly a user interface. This applies to anything, right? Like websites, Revit apps, apps for your cell phone or anything, and it has a lot of details on what type of icons should you use, what type of color palettes. Let's say that the color palettes of your company use a lot of blue. Well, you can input the color of your company. It will showcase what colors match with that specific blue tone. It gives you examples of, I don't know, if I open one of them, that example is going to show me how they combine different colors and fonts and aesthetics and different forms and separation between elements and these kind of things that gives you a lot of rhythm, because something it's really true. If you're adding it doesn't look good, nobody's going to use it. It's like everything, like you always want to try to make everything nicer, because if it looks good, it gives you trust and it's easier to use most of the times. So I really recommend this when you're considering the design of your tool. And then after you take all those guidelines, it's important to have in mind a couple of things like, this is an acronym, keep it stupid simple as possible. Like the simple your tool is, the easier it will be to use. Then remember that it's not everything, it's not about beauty, but also remember that any decision that you take, like, hey, I'm going to move this button here or this list here or there or whatever, always think about the user. What is going to be easier for your user if you do this or that? And then finally, yes, aesthetics. They're important. Like your tool should look good. I like to bring this example. This is something we did a couple of years ago. These are two different forms, and they're doing exactly the same thing. We did this, and it was confusing. You had to go to security, user configuration, and it was not clear what you have to do here. And then we redesigned it completely, and we ended up with this. Super easy to use, like logging, where you put your user, your password, and then you can log in or register or whatever you want to do. At first glance, you know what this is doing. You don't know what the hell these global settings are doing, and they have the same purpose. So this is why the design it's important. And then these are a couple of examples of these are 3 different add-ins that we have. That, by the way, these are free and they're available in our website. They all look. We always try to make everything look the same. So we have a standard of colors. We have a standard of fonts. We have a standard on where we put the title, where we put the version of the add-in, and those kind of things. So it's not only easier for your users because they can get used to what you do, but also it's also easier for you to design because now you have a standard and you know where everything should be or how everything should be designed. After you have gathered all your requirements, you have designed the back end with your architecture and the front end with your interface, you have to start planning. And for me, this is a great analogy. Why? Because like factories nowadays, what they can automate, they automate in the process. Like if they can put a robot to do like things like, I don't know, weld things, weld the doors, or I don't know, paint the car, they're gonna do it because it's gonna be cheaper, it's gonna be faster, it's gonna be in a standard, it's gonna be like in a standardized way. So when you're coding, it's exactly the same thing. It's important that if you can automate part of the coding, you do it. And also, you have to divide things in as small as possible. And then you have to make sure that it's everything is like an assembly line. Your developer should be like this guy here working on the assembly line. He should get to the computer. He should know exactly what he has to do. Like, hey, I'm going to take this part, I'm going to put it to this engine, and I'm going to do this or that. He has to get to the office every day and know exactly what he has to do. And that leads to more efficient processes. Taking that thought into account, when the first thing you do is you take all the requirements, all the design and everything, and you split it in as many parts as possible, like I previously said. I always think like a mechanical part, like I'm going to split it in bolts, nuts. I'm going to split it in parts, right, that cannot be divided. Like I cannot split this part in the middle. So with the software, it's the same thing. Try to split everything as possible because like, hey, I'm coding this small piece of code, like I previously showed here in the code, and it's just going to do one thing. So then I quickly do the thing, I quickly test the thing, and I know it's failure proof. It's not going to fail. So you divide everything into small pieces, and then you start assigning these pieces to different people. And this, and here comes an interesting. There are companies that you might be the only developer in your company. You might not be a developer at all. You might not have a developer in your company, or you can also might have like a team of 50 developers. No matter how many people you have or you don't have, you might have to consider the return of investment again. You might want to say like, we don't know how to do this, but one of the developers can learn like a new language and can do this. But that developer might take, I don't know, 3 months to develop a task that someone who knows how to do it might do it in hours. And this is like a real life example. I have seen these kind of things many times. People in our company taking, or people in other companies taking like a month and us knowing how to do it, or vice versa, and you compare the the times, and it's crazy. So it's important, like, hey, if you want to invest in someone to learn it in your company, maybe you want to say like, hey, yeah, take the 3 months so you learn how to do it. Or you can think of the return of investment, and maybe you can just like vendorize that or hire someone externally to come do that thing in a couple of hours. That's it. So it's important to before assigning a task to a resource, know if that's the best resource to do it or not, no matter if it is internal or external. Then, and this is simple, you set up a place where you're gonna saved all your files. It can be a Google Drive, a Dropbox, Procore. It could be OneDrive, like the case that I'm showing. We use OneDrive. No matter what you're doing, but do it. Have a specific folder in a standardized way before starting to code. What I'm doing here, I'm setting all the steps so I can create an assembly line before even start to code. After that, I'm going to create a GitHub repository. For the ones who don't know, GitHub repositories is where your code is going to live. Is like BIM 360 for Revit models, but for programming code. And again, it's important to set up as a repository, because sometimes your software is so big that you might need like 3 repositories. So, and this is another real life example, like you start working in one repository and then you realize in the middle of a process after 3 months of working, like, hey, we should divide this. This is too big to be in just one repository. And then it's painful to divide code, take it to another repository. It's like divided a Revit model. It's not nice and takes time. So if you think at the beginning of the project, like, hey, my project is going to be this big, I know how many repositories I'm going to need and how to set up those repositories. GitHub is just looks like this. It's just files and branches of code that I can work in different features. And when my feature is done in my branch, I can merge with the master. And then it's like synchronizing in a Revit model. Exactly the same. I work in my local file. Then when I want to merge, and I'm sure about what I have already done and it's working, I merge that feature to there. And again, this is another example why we need to divide into small pieces. If you're maybe working in something really big and your colleagues are working in something really big at the same time, you are all done after a couple of months, and when you try to merge, there's so many conflicts between each other. But if you're doing small things, you can every day test and see if you're creating conflicts or not. Pretty much the same analogies when you're working in a collaboration or coordination project in Revit. Pretty much the same thing. And then creating a README file on your repository. This is just more documentation that is going to show a brief description of your project. What dependencies are you going to use? This can be called the Revit families. Like we can call actions from other projects, so we don't have to recode things. Versions, like how many versions do I have? My current version is stable or not? How to install the software? How to contribute? Like, let's say that you leave it there for any in your company to work with you, or you stop the project and then you want to continue in a couple of months. It's important that you have details on how you can contribute to that project. And then an about, which is just general information. An example would be, this is a super simple adding tool that I'm using as an example for you. I'm just showing the icon, what the Revit versions are for this specific tool, the dependencies, how can I install it, and I can even add the hyperlink to the App Store. We have it uploaded to the App Store. You can upload it to your website, or like how to contribute and about us, and those kind of things that you can put there. And then DevOps. DevOps, it's a really fancy word lately in the development world, because companies like huge companies like Facebook, Google are paying a lot of attention to these kind of things, because it proves that saves a lot of time and gives you more quality to your software. Basically, what DevOps is what's in the middle between the developer and the user. The developer, they code. But then you have to create, for example, an installer. Then you have to upload the installer to a website so you can download that installer. All that process is DevOps. The way you're testing your software, like, are you going to do it manually? Like, are you going to try it, everything, or are you going to automate the way it's tested? All those kind of things, that it's everything that adds to create that famous assembly line that I have already told you. That's DevOps, and it's important, and I'm going to show you why. This is an example of the type of pipeline that we use for DevOps. Basically, this is the programmer. They push code into the GitHub repository that I showed you. And then every time they click like save or synchronize in Revit, you could call it, automatically this is uploaded online. And depending if it is something that it's for testing, that it's for the user to test, or it's ready for the users to use on production. So these are the three different ways that this is released. And the three ways is going to pretty much do the same thing. It's going to create an URL where you're going to be able to download your installer, your latest and greatest installer. This is important because, and this happened to me a couple of times, to be honest, in the past. Someone comes to you and reports to you a bug, like super crazy, like, hey, you know what? A client told me today that I have to submit a couple of construction drawings to the site, and I need some automatic tagging, and I have to do it now. And you're a programmer, and it's like, yeah, I will fix that bug so it works for you. You start coding, you send it to them, like through Skype or email or whatever. He downloads the file. He comes to me again. No, it's not working. Like, it's still doing the same thing. I try to fix everything again. I send it again, and I check, and the problem is, like, he's, for example, not overwriting his file, so it's not the current version. Or the other thing that might be happening is that he's not downloading from the place that I told him, and those kind of things. And if you do it one time, it might look silly, like, well, it's not that complicated. But when you're working with code and you need, like, to fix bugs quickly, you might try, I don't know, 20 times, 30 times. So in a day, if you have 30 files at the end, you don't know if you're using the last file or not the last file. And in the middle, he reports two new bugs. So now you have 3 bugs, but which bug should I fix first? And it gets super messy and crazy. So it's important that you have set up a process where you do this, and it's deployed for the person who is going to do testing internally. And then I think I have a question or something.
No, it's basically just saying that's it's 2:38.
Okay, yeah, 10 minutes more and we're ready.
Okay.
Those are the 10 minutes that you stole from me at the beginning.
Okay, I mean because of the questions and answers. Yeah.
Yeah.
Okay,
Yeah,
good.
just 10 minutes
Yeah.
and we're done.
Okay.
Thank you. And then we come to the development phase. Remember all the things that we have done previous to development. First thing, it's important to have a template, a Visual Studio template. And this is an example of a Visual Studio template that what I do is I come here, Revit add-in, I click next, I create a new project, and I do save or build, how it's called in programming, and automatically I get a new add-in, which is test add-in here. It's an empty add-in, it's not doing anything, but it's a huge base that saves you a lot of time when you're starting a new project. So it's important for you to have a Visual Studio template for your add-in. Let me showcase again. Okay. Then these are good practices for coding, which are like naming conventions, comments. So you're describing what you're doing in your code. So if someone else comes, they know what you're doing. properties versus variables. One action per class, like I said. In our case, we use the singleton pattern. One statement per line, etc., etc. This are plenty of guidelines in internet that you can dig into it and make sure you're following them. Another thing that it's super important, because will save you a lot of time, it's having a core. The way this works, and it's a little bit abstract, is instead of me, let's say that this is my project when I'm coding, instead of me using this function, which is like just checking if this is a number or a text, I'm gonna add this to my core, which is a complete different project. And then I'm gonna link that project and call that functions through my project. What I'm doing that, because then all the stuff that I do for this project is gonna work for this project as well. And I'm making my core bigger and bigger. And then I don't have to recode things. I just look into my code, into my core, sorry, and I make sure that I already have those functionalities. So then again, the assembly line, my programmer, instead of just coding every day, he used Legos. Oh, I already have these Legos. I'm going to put it in my project. So you end up with something like a core of a project and something like this, a core feeding all your different projects. Then testing. Testing is important as well. To run sanity checks, make sure everything is working. It's not broken. It's not showing me crazy warnings or like, hey, be careful with this, or closing suddenly or super buggy. User case test is also important to define how exactly the tool is going to work. So then the tester can exactly know what he has to test. Exploratory testing, and quality level to define how much quality you want for your project or not. Almost there. And then make sure that you always test in a virtual computer, where it is Amazon Web Services or Azure or any other virtual computer, because that will make sure that your computer is like a generic computer. It's not that your computer that you might have references or might have stuff that installed that is helping you to work, and it's the typical like, hey, in my computer the solution works, but when someone else is using it, it doesn't. So make sure when you test it, you don't do it in your computer. Finally, publications. Just make tutorials. If people, they don't know how to use a tool, they are not going to use it. Make sure you upload it to YouTube or any other like private repository you might have, but make sure it's available for everybody. If people don't know how to use it, they're not going to use it, even if it is going to save them a huge amount of time. Another thing, if you're thinking on using it internally in your company, make sure you have a website or something like that. In our case, it's here, and we have details on how it's supposed to work, and you can go to GitHub or the App Store. But make sure you have somewhere where people can look into it and know how it works, or to contact you too. If it is public, and I don't know, we do a lot of free announcer stuff, you can always use the App Store, Autodesk App Store, like we are doing right now. Then make sure you're using an SSL encryption. This is like a service socket layer, which is a standard of security that if you don't have it, it's gonna pop up a super weird warning saying like, hey, you really want to use this, or are you sure you want to open this? It might be dangerous. So use that. It's a simple step to do. And finally, feedback, which is important as well. Make sure you we'll use surveys. In our case, we use a lot of SurveyMonkey or Google Forms for surveys. Like, are you happy with the tool? Do you think it's useful? Do you like it? It's fast enough? Do you have any bugs to report? And those kind of things that then you can adds a lot of value to know not only if the tool is useful, but to know if your process is it's good and robust enough. And then another thing that, and this is the last one, another thing that you might do, and a lot of developers do, is you trigger on events. Let's say every time you open an app, it will go to a database, to my internal database, and I will know that you as a user, you're using my app. So I can know how many users are using my app in my company, how much time they do have opened the app, what are they doing with the app, like are they clicking all the buttons, are they having troubles or not, and I can have a log, automatic log for everybody that is using my app automatically. You can code that, and a lot of tools like Dynamo, for example, they use that, or like they get logs of what people is doing so they can improve the tool. And you end up with this is just one register of one use of a tool, like this user, John Miller, this is the user of Revit, opened the tool on this date, he clicked this button, and then he closed it. So I can know people, it's opening the tool and it's closing it like fast or things like that. I can know that something is not going right, or I can start looking into patterns and know. And then I can feed the whole process if I need to basically improve something down the road, like bugs or speed, it can be as well. So that would be all for today's webinar. Just two things before the questions. We are organizing a free BIM AEC online hackathon between the 27th and the 30th of May. So this is a great experience for all of you who want to create a new tool, or Axel, do you want to say something?
Yes, actually, well, a comment around that. We're going to have like really great judges, very smart people in our industry. We are just getting some confirmations of who are going to be judges. We're not going to publish them now until we have the final confirmation. But anyways, we thought this would be an interesting get together of people that have ideas that or problems that they like to solve within the industry, and have people evaluate these ideas, smart people evaluate these ideas. Hey, I think, Valentin, we have a good question already pumping up. It says great presentation.
Just 1 second. And then one more thing. If you like this presentation on June the 10th, we're going to give another one on how to use Autodesk Forge Viewer. So stay tuned and join us then if you like. And now, yes, we are ready for any questions. Go ahead.
It says, in order to program with the Revit API, do we have to learn the entire C++ program, or is there a certain function will be useful for non-programmers? I was about to mention engine, but you go ahead.
Well, or Dynamo, or any or any other visual programming script. Engine, it's a visual programming tool that we have developed, a cloud visual programming tool. Dynamo, it's a visual programming from Revit, and Grasshopper, it's a visual programming for Rhino. So basically, that would be a good starting point if you don't have like coding skills. Visual programming, what it does is you're coding without actually knowing how to code. You're just taking notes that are behind it. There is a lot of code. So it will at least give you the basic stuff, And then when you feel you can use them, then you can start learning C#, because to actually develop add-ins, yes, you need to know C#, or you can develop the whole process that we have just shown without actually code the C# thing and just tell somebody else to do it. Like I showed, it's just 30% or less of the process. The biggest thing is all the rest. Okay, then another one, my next question was around Forge, and thanks for organizing, looks forward to it.
The visual programming tool is great. It works great in Navisworks. Saved me a lot of time organizing. If classes, check it out.
Okay, cool. Thanks for that.
No,
Any other questions, guys?
how can companies share files with external partners? We use our internal network for staff, but then when they have to share files, we have to upload something like Dropbox, and we continue syncing files. We also then have issues with file locking.
Upload. How can
Russ question, I guess.
Let me. Okay. Want to share files? We have to upload. Have issues with file locking. Russ, do you mean like binaries, like DLL files or executable files? So a chance you can share. You can be more specific on what type of files. Oh, cut-up files. Well, like there are. You can always use like tools like Procore or those kind of things, or any other, yeah, a version control tool like Aconex or those kind of things for like cat files. You can use GitHub itself, but I wouldn't recommend it for that. Or you can set up, like we do have set up a process of DevOps for our development, where every time that we create a project, we use a database, and that database creates an URL, but it's like heavy lifting maybe for just a couple of cat files. That's what I think. Any other questions? Don't be shy.
Of course, if you have more questions, I mean, we can. You can definitely email us. Maybe we'll send you an email. It's going to be innovation@engworks.com. I think that's the right email, Valentin, right?
Yes, that's the right email. Can you type it there, maybe? That would be
yes.
helpful.
Someone is asking there, can Python be used?
Yes, you can use Python. Just be aware of two things if you're using Python. Basically, the API was created in C and C#, the Revit API, for example. And they do have the ability to use Iron Python, which is in essential, it's a Python implementation of C#. The only thing that you have to have in mind is like C#, it's the one that has more documentation on the community, so it's easier to find solutions. But that's the only difference with C#. Otherwise, you can completely develop add-ins or macros or anything like that using Python, or Ruby on Rails, or Visual Basic.
So, and of course, any help that you guys need in developing app, like Revit apps and stuff like that. Revit add-ins. Definitely, we are happy to help.
Yeah, or questions that you want to start like coding or something like that. We always like to share with the community, or knowledge or We do like Rhino things or Navi things, CAD, Forge, a lot of the tools of the ecosystem. So if you have any doubts and you want to start down this road, just do not hesitate on contacting us. We are always happy to help.
So if there is nothing else, I guess we wrap it up. Thank you everyone again. Thank you, Valentin. It was really nice content, and we look forward to seeing you in our next webinar. And again, feel free to email us at innovation@engworks.com, and we go from there.
Okay, thank you. On the last question, you can email me, and I can give you a detail. And one more thing,
slides will be available.
Slides will be available. Yeah, exactly.
And the video too, of this, the recording too.
Okay, thanks everybody.
Thank you.
Have a good one. Stay safe.